Alrighty, so today we're going to look at if-then statement or implication statement. So that's on page 6. So the idea of implication statements are statements which are written in the form of if P, then Q. So if something happens, then something else will happen. So it's a kind of a consequence statement. Another way to phrase it is P implies Q. The mathematical notation for that is like a double arrow or double line arrow. So P double line arrow Q. So we say that P is the hypothesis because if P happens, and then Q is the conclusion because then Q, the consequence happens. So if P, then Q, or P implies Q. So a mathematical implication could be if x is 5, then the result x squared must be equal to 25 because 5 squared is 25. Another way to write that using the mathematical notation is x equals 5, arrow, double line arrow, because that's the implies, x squared equals 25. Makes sense? If you tell me that x is 5, then the result, the consequence is x squared must be 25. The thing to note that is implication statements only tell you what happens if P is true. So if x is 5, then you know for sure x squared is 25. It does not necessarily tell you what happens if Q is true. So if you tell me if x squared is 25, I don't know for sure what x is. X could be positive 5 or x could be negative 5. I don't know what P is. So if-then statements only work if the P is true. So if you show up to work on Monday, then you'll get the job. And that's like a real life scenario. To disprove the implicative statement, so to show that P implies Q is false, you need to find a scenario where P is true but Q is false. So for example, if you show up to work on Monday, then you will get the job, right? So P is show up to work on Monday, Q is you will get the job. So if you show up to work on Monday and you don't get the job, then that's a false statement. And that's how you prove that an if-then statement is false. The negation or the opposite of PQ is a false statement because the opposite of if you show up to work on Monday and you will get it, then you will get a job. So if you show up to work on Monday and you don't get a job, then it's a lie. Your potential boss has lied to you that you don't have a job. In general, the negation of P implies Q is P and not Q. Again, think of the if you show up to work on Monday, then you will get the job. The opposite of that is you show up to work on Monday and you don't get the job because that's a lie told to you. So that's the opposite statement. Example 13, putting it in back to math again. Figure out if the following statements are true. So part A, if a shape has 4 sides, then it is a rectangle. So let's figure out our P's and Q's. So let P equal the statement a shape has 4 sides. Then Q is the statement it is a rectangle. So if you think about it, if a shape has 4 sides, then it is a rectangle. Is this true? Well, can you find me a shape which has 4 sides and not necessarily a rectangle? Yeah, a parallelogram maybe, or a rhombus even, right? A kite. Yeah, there's many counter examples that you can give me a 4-sided shape which is not necessarily a rectangle. So this statement is false. So we will write a counter example. So to show to the reader why it is wrong, let's give a counter example. Parallelogram, or pick your favorite 4-sided shape of choice which is not a rectangle. Parallelogram has 4 sides, but it is not a rectangle. Therefore, P implies Q is false, saying that just because the shape has 4 sides does not mean that it is always a rectangle. B says, if x cubed is bigger than 8, then x is bigger than 0. Well, let's define our p's and q's. So p is the first statement, the if statement. So let p be x cubed is bigger than 8, and let q be the statement x is bigger than 0. So you're asking, if we know that x cubed is bigger than 8, do we know for sure that x is also positive? Well, let's concentrate on p first. What does x cubed bigger than 8 means? So consider p, which is x cubed is bigger than 8. So throw back to year 10 methods when you looked at, well, rearranging and solving inequalities. If x cubed is bigger than 8, then cube rooting is the opposite of cubing. So x is bigger than the cube root of 8. Remembering in solving inequalities, you only flip the sign if you're multiplying or dividing by a negative number, but in this case we're not. So we leave the sign pointing to the right, so it's fine there. So if x cubed is bigger than 8, then we know for sure that x is bigger than 2. So what does this mean in terms of x is bigger than 0? So it might help to draw a number line diagram. So if I draw a number line, use a ruler. So you have 0, you have 2, and a number line. P is true means that x is always bigger than 2. So you do an open circle on top of 2 because it's not bigger than or equal to. Bigger than 2 means everything above 2. So I'm going to draw a line to the right of 2 because that's everything above 2. So this is if P is true. Then we have that everything to the right of 2, not including 2, holds. What does Q mean? Well, Q means everything that's bigger than 0. So you draw an open circle on top of 0 because it does not include 0. And everything to the right of that is Q. So Q is true if everything's to the right of 0. So essentially you're asking yourself, if x cubed is bigger than 8, in other words, if x is bigger than 2, is that value always bigger than 0? Yeah, it is, because your blue arrow part is part of the red. So if P is true, then Q is also true, because you know it's part of the red. So we can write that if P is true, then Q is also true. So therefore P implies Q is true. So if x cubed is bigger than 8, then we must know that x is positive, because the answer has to be bigger than 2. If it's bigger than 2, it has to be bigger than 0, and that's a consequence. So that's if then, an implication statement. Now here's a bit of a trickier keyword over the page. We say this converse, not the shoes, not the brand Converse, but mathematical converse. The converse of P implies Q is Q implies P. So converse is switching the order around. It, be careful, may or may not be true. It's a statement. It might not be a true statement though. So for example, if x is 5, if x equals to 5, then x squared is 25. That's the original statement. The converse of that statement is you switch the order around. If x squared is equal to 25, then x equals 5. So right now we're just writing the statements. So if the original statement is if x equals 5, then x squared is 25, which is a true statement, the converse of that means I swap the p and q around so that if x squared is equal to 25, then x is equal to 5. Is this statement true or false? Well, it's not necessarily that x is always positive 5, because you could have x is negative 5, right? So this is a false converse statement, because x could also be plus or minus 5. So if x squared is 25, not always x is positive 5. It could also mean that x is negative 5, so the converse is false. Let's do another example. If, for example, x is equal to 3, then x cubed is 27. That's a true statement. If I give you the number 3 and you work out 3 cubed, for sure you get 27. So that's a true implication statement. If we decide to write the converse statement of that, I can't spell, converse, it says switch the order around. So if x cubed is 27, then x must be 3. When we think about it, when we're cube rooting 27, the only option is x equals 3. So this is a true statement. So this converse statement is true. Because if you give me x cubed is 27, solving for x, cube rooting it, it has to be positive 3. It can't be a negative 3. And that's the only solution. So our implication is correct. So converse statements essentially can be true, can be false, but to write a converse statement, you just flip the order of Q and P around. Why is converse important? Because if we know that P implies Q is true and Q implies P is true, then we can write a equivalent statement. So in other words, P if and only if Q. So if P implies Q is one way and Q implies P is the other way, if and only if, or if is a double implication because both statements work is true for both ways. So for example, from above, we can say that x equals 5 implies x squared equals 25, but we can't draw the arrow the other way around because the backwards arrow is not true. In contrast, for the x equals 3, I can do an if or if and only if arrow because going forwards, if x equals 3, then x cubed must be 27, and going backwards, if x cubed is 27, then x must be 3. So both statements work. Both statements are true. So you can only if and only if P implies Q and Q implies P, it works like a two-way street. Otherwise, it's just a one-way street. It's an if-then, a basic if-then statement. Example 14 is kind of mixing a bit of words along. So for each of the following scenarios, write the converse statement, which may or may not be true, and figure out if it is true or not. Because if the converse is not true, then it's a pure implication. But if the converse is true, then we can make an equivalence, like a double arrow statement. So for part A, if an animal is a kangaroo, then it is a marsupial. So my P statement is an animal is a kangaroo, because that's my first part of my if-then. My Q statement is it is a marsupial, or the animal is a marsupial. The converse is Q implies P, because P implies Q is the original statement. So the converse, flip the order around, Q implies P. So which is the statement if the animal is a marsupial, then it is a kangaroo. So it's I'm just writing the statement. Doesn't mean it has to be true. Now we use a brain and think, well, is this statement true? If you give me an animal that is a marsupial, must it be a kangaroo? No. What else are marsupials? Like, are koalas marsupials? Yeah, koalas are the marsupials. So just because you give me a marsupial, which is a koala, doesn't mean it has to be a kangaroo. So therefore, converse, it's not therefore. So for example, consider a koala. It is a marsupial, but not a kangaroo. So converse is false, or converse statement is false. Therefore, it's only a P implies Q. There's no double arrow because the converse statement is not true. B, if a number is odd, then n squared is odd. So again, identify your p's and q's. Your p statement is n is odd. Your q statement is n squared is odd. The converse is swap the order around. Q implies p. So if n squared is odd, then n is odd. For now, believe me, trust me, it is mathematically true. We will end up proving this in example 20 in like a few pages down. But for now, just believe in me, have faith in me that converse is true. Converse is true. Why? Because we will prove it in example 20. We will do it on a later day. Therefore, we can write P if and only if Q, because both the P implies Q is true and the Q implies P is true. The converse is also true, so we can do an if arrow, if and only if. That's pretty much it for today. So if you understand P implies Q and the converse, which may or may not be true, and that's we're good. So exercise 4.2, question 7, A, B, E, F, and question 8. That's it.